Hi, this is Mrs. Clark, and this is my video for Algebra 1 on is the rate of change constant? So we will be looking at rates of change in input and output tables and deciding whether the rate of change is constant or not. So in our first unit, we looked at the differences as we go down the table, and we were looking for a common difference when we were looking at arithmetic or geometric sequences. Similarly, now we're going to be using the same idea as we did before, but we're going to be looking at those differences and determining the rate of change. So we'll be looking at the change in the inputs and outputs, both columns, and we'll be writing our ratio, which we call the rate of change. So in order to do that, we're going to need to remember that we need to look at the change in y over the change in x. That is our rate of change. So we're going to need to write that ratio as a fraction, and we're going to then need to remember to reduce it. After we reduce that rate of change, we're going to check to make sure that it remains constant all the way down the table. So here's how we're going to do that. Okay, so in order to look at the rate of change, we need to look at the differences as I go down the x or input column, and the differences as I go down the y or the output column. I'm going to make a note here. Input is x, output is y. Okay, so when I'm looking at the change, I'm looking at what is happening to x as I go down the table, but I'm most interested in what's happening to x from negative 3 to negative 1. This is negative. It's hard to see on your paper. So we have negative 3 going to negative 1. We want to know what is the change. So you see I've made these little arrows here. I want to know as negative 3 goes to negative 1, does it increase? Does it decrease? How much does it change? So we can think about it in a couple different ways. I can think of it as a pure math problem. And if I'm going to think of it as what's the difference, I need to think of negative 1 is subtracting negative 3, because that's what a difference is. Difference is subtraction. So I would do negative 1 minus negative 3. So it's kind of like the new one minus the old one. And since I have this double negative here in between, that really is the same thing as negative 1 plus 3. Which if I do negative 1 plus 3, I'm going to get 2. And that was like a pure math way of finding the difference. I can also think of it like on a number line. If I'm going to go from negative 3 to negative 1, how many am I going to go in which direction? So I'm moving this way, which is the positive direction, as I move from negative 3 to negative 1. And how do I move from negative 3 to negative 1? I move 2 steps in the positive direction, so it's a positive 2 for our change. So you might be able to see that this is increasing from negative 3 to negative 1, so it's increasing by 2, so it's a positive 2. You might want to do the subtraction of the new minus the old, or the second minus the first, and get your change that way. This will help you later on when we calculate slope, to help you practice that as well. So we can continue to do it that way, but you can also think of it kind of logically what makes the most sense. So as I go from negative 1 to positive 3, that's 3 minus negative 1, which is 3 plus 1, which is 4. So that's a change of 4 this time. Then from 3 to 6, 6 minus 3 is 3. So it's a change of 3 this time, increasing again. And from 6 to 7, 7 minus 6 is 1, so it's only a change of 1. Now as I look down, it does not appear to have a common difference. So let's check this side as well. We want to look at the ratios after. So here it's going to be the same idea. 1 minus negative 3. 1 minus negative, oh, I missed a negative here. 1 minus negative 3 is going to be 1 plus 3, which is going to be a change of 4, so it's increasing 4. From 1 to 9, 9 minus 1 is 8, that's an increase of 8. From 9 to 15, that's 15 minus 9, which is 6, so it's an increase of 6. And then 15 to 17, 17 minus 15 is 2, an increase of 2. So my x's were increasing and my y's were increasing all the way along, steadily along the table. So the only thing that I have to do next is actually look at this ratio, because these don't look constant and these don't look constant. But that's not what's important here. What's important is how is the y changing compared to how the x is changing. So I'm going to cover these up for a second because I want to look at the change in y over here and the change in x over there, and I want to write it as a fraction. So I've got 4 over here for my change in y and 2 over here for my change in x. So that's 4 over 2 for that first one. When I go to the next one, I've got 8 on this side and 4 on that side. So that's 8 over 4. When I go to the next one, I have a change of 6 and a change of 3. So that's 6 over 3. When I go to the last one, a 2 and a 1. So again, these ratios do not look the same, but I have to remember to reduce them. And that means reduce them to their lowest fraction. So 4 over 2 reduces to 2 over 1. I can divide by 2 on the top and divide by 2 on the bottom, and that will give me 2 over 1. When I go to 8 over 4, I can divide by 4 on the top and 4 on the bottom, and that's going to give me 2 over 1. When I go to this next one, I can divide by 3 on the top and 3 on the bottom. It's going to give me 2 over 1. And the last one is already reduced as 2 over 1. So when I go ahead and look at them, I see that they are all the same rate of change all the way down once they're reduced. So when that is true, I can say yes, the rate of change is constant. Now I know your paper is smaller than mine, so you're going to have to write a little bit smaller than me, but I know you can fit it all on there because I've done it on that same size paper before. Okay, you just have to write small. All right, so we're going to do these ones at the bottom. We're going to go through these examples. You're going to determine if each table has a constant rate of change. You're going to show your work. You're going to, at the bottom, you're going to list what the rate of change is. Was it constant or not? You're going to do your work out to list your different rates of change. You're going to say whether it's constant or not, and then if it is, you're going to say what the final ratio is. Up here, our final ratio was 2 over 1. So if you feel like you got it, I would pause the video now and try it on your own, and then you can jump back in and catch up and see if you did it correctly. I'm going to go pretty quickly through these. 15 minus 10 is 5, so that's a change in 5. 25 minus 15 is 10, that's a change in 10. 30 minus 25 is a change in 5. 45 minus 30 is 15. So right now that's not looking very constant, but I'm going to have to do my y's as well. 6 minus 2 is 4, change in 4. 14 minus 6 is 8, that's a change in 8. 18 minus 14 is 4, it's a change in 4. And 30 minus 18 is 12. So now to determine if our rate of change is constant, we're going to have to look at the ratios. 4 over 5 for the first one, 8 over 10 for the second one, 4 over 5 for the next one, 12 over 15 for the last one. So is that a constant rate of change? Well, I have to think about these fractions. 2 of them are 4/5, the other one is 8/10, and then 12/15. So 8/10 I can divide the top and bottom by 2. Then I'll get 4/5, so that works. And then 12 over 15 can divide the top and bottom by 3. So 4 over 5, so technically they're all 4 over 5. So it is a constant rate of change, and the ratio is going to be change in y over change in x is 4 over 5. So even though this one is changing more, it's 3 4s, and then this is changing by 3 5s, so the ratio is staying the same. All right, go ahead and pause the video and try the next one. All right, so don't have a lot of room here. Negative 8 minus 12. Oh, sorry, minus negative 12. It's going to be negative 8 plus 12, which is going to be 4. Negative 8 minus negative 4 minus negative 8 is going to be negative 4 plus 8, which is going to be 4, increasing by 4. From negative 4 to 0, 0 minus negative 4 is going to be 4. And then here we got 4 minus 0, which is going to be 4 also. So we got 4, 4, 4, 4. Well, that's looking good so far. Let's check this side. 7 minus 9 is negative 2. 6 minus 7 is negative 1. Uh-oh. 5 minus 6 is negative 1. And 3 minus 5 is negative 2. So our ratios are negative 2 over 4, negative 1 over 4, negative 1 over 4, negative 2 over 4. Those are not constant ratios. Negative 2/4, negative 1/4, not the same. So this NA, not applicable. We can't answer that question because they're not constant. All right. Pause it and try this last one. All right, 12 minus 14 is negative 2. 10 minus 12 is negative 2. 6 minus 10 is negative 4. 0 minus 6 is negative 6. Okay, if you can't fit all this work on your paper, I should have mentioned this earlier, but you can always use like a Post-it note and just stick that into your notebook if you want to show the work, if you can't squeeze it in, because I know your paper is smaller than mine. All right, so negative 2, negative 2, negative 4, negative 6. All right, this side, we got 8 minus 3 is 5. These are easy. 13 minus 8 is 5. 23 minus 13 is 10. And 38 minus 23 is 15. So I've got 5 over negative 2, 5 over negative 2, so far so good. 10 over negative 4, and 15 over negative 6. So I really got to figure out if these last two are going to simplify into 5 over negative 2. So 10 over negative 4, I can divide by 2, divide by 2. That'll be 5 over negative 2. And 15 over negative 6, I can divide by 3. So that's 5 over negative 2. So yes, it is constant, and our ratio, change in y over change in x, is 5 over negative 2. There you go. Go ahead and glue it into your notebook, and you may move on to the next thing. Thanks for watching.